If we want to have a better understanding of a star, a planet, a galaxy, or anything in the universe in general, we must, whether we like it or not, study the history of the origin of that body. As for the planet Mars, the hero of our current topic, according to scientist theories, it is concluded that during the formation of the solar system 4.5 billion years ago, Mars was formed as a result of the accidental accumulation of material from a protoplanetary disk orbiting the Sun. But this accumulation was not very productive. For example, the diameter of Mars is almost twice the diameter of our planet, that is, 6,780 kilometers, and with this size, Mars corresponds to only 11% of the mass of our planet. Moreover, the density of Mars is considered much lighter than the density of our planet. Mars has a density of 3.9 grams per cubic centimeter, and our planet has a density of 5.5 grams per cubic centimeter. The evolution of Mars is mainly divided into three periods. The first is the Noachic period, which covers the period from 4.5 to 3.5 billion years ago. This period corresponds to the oldest surface formation period of Mars. Surfaces during Noah's time consisted of many large impact crater scars, and it is believed that the Tharsis bulging, valleys, volcanic mountains, erosion, floods, and oceans were formed during this period. This was followed by the Hesperine period, which spans from 3.5 to 3.3 and 2.9 billion years ago. This period is characterized by wide lava plains. After that, the Amazonian period began, which spans between 3.3 and 2.9 billion years ago to the present. Meteorite craters during this period are few, but they are very diverse. Although the hypothesis that Mars underwent a heavy evening bombardment, like the fate of many planets in the solar system, has been questioned, there is a large impact crater that was formed when a Pluto-sized object crashed into the North Pole of Mars about 4 billion years ago in the middle of the Noachic era. Its size is 10,600 by 8,500 kilometers, which is equal to the total area of Eurasia and Australia. Mars is heavily cratered, with a total of 43,000 craters, 5 kilometers or larger in diameter. The largest exposed crater is Hellas, which is 2,300 km wide and 7 kilometers deep. There are other notable impact features, such as the 1,800 km wide Argyre crater and the 1,500 km diameter Isidis, and of course the fraction of large craters of this size on the planet's surface. Very noticeable. There is one more important factor to consider here, and this process depends on the weight and size of Mars, that is, since the diameter of Mars is 2 times smaller than the diameter of our planet. Its weight is 9 times lighter than the weight of our planet, so the gravity of Mars is almost 3 times weaker than the gravity of the Earth. Of course, this weak gravity makes space objects much less attractive. Due to the fact that the diameter of Mars is 2 times smaller than the diameter of our planet, its impact-receiving surface is also very narrow. If we compare the surface of Mars with that of the Earth, its surface is only 28% of the surface of the Earth, which means 144 million square kilometers. While the surface of our planet is 510 million square kilometers. Of course, because of this, the bombardment by asteroids, comets, meteorites and other similar bodies is twice less than our planet. But because Mars is close to the asteroid belt, the threat from the asteroid belt is greater, and so is the threat from comets. Mars is mostly hit by short-period comets, in other words comets in the orbit of Jupiter. In addition, the things that amaze us on the surface of Mars are not only craters, because there are many wonders on the surface of Mars that are the products of tectonic processes. One of them is the Great Canyon Valles Marineris. Its length is 4,000 kilometers, which is equal to the length of Europe, and the depth of this canyon it reaches up to 7 kilometers. Valles Marineris is so large that it stretches a fifth of the circumference of Mars. If you need to compare, the length of the Big Canyon on our planet is only 446 kilometers and the depth is almost 2 kilometers. In addition to craters and canyons, the Martian surface is also home to volcanic mountains. The vast mountainous region of Tharsis contains several extinct volcanoes, including the volcanic shield mountain Olympus Mons. The width of the volcano is more than 600 kilometers. Because the mountain is so large, it is difficult to give an exact height due to the complex structure of its edges. Because there is no sea level on Mars, it is difficult to measure the height of this mountain from any point on the surface of the planet. In this regard, the Amazon plains are the best option for measuring the height of the mountain, and the height from this point to the top of the mountain is close to 26 kilometers. This height is about 3 times higher than Mount Everest. At this rate, Olympus Mons may be the tallest mountain in the solar system, and is rivaled by Resilvia Peak on the asteroid Vesta, which is nearly the same height as Olympus Mons. Most of the mountains on our planet are the product of tectonic processes, and the percentage of mountains formed by volcanoes is much smaller. This mountain of the planet Mars, although it is much higher than the mountains on Earth, is made entirely of volcanoes. Continuing on the subject, these are the moons of Mars, but these moons are not as big as our moon, they are very small. Mars has 2 moons, Phobos, the larger one, about 22 kilometers in diameter, and Deimos, the smaller one, about 12 kilometers in diameter, orbiting close to the planet. The origin of these 2 moons is unknown, but a popular theory suggests that they may be asteroids that fell into the orbit of Mars. The reason we add the moons of Mars to the topic of Martian evolution is that another hypothesis about the origin of these moons suggests that they are remnants of the planetary material that formed Mars during the formation of the solar system. There is also a third theory, according to which these moons are the result of the impact of a third body, that is, as a result of the impact of a huge body on our planet, the moon appeared. As for the current position of these moons, since Phobos' orbit, unlike that of Deimos, is below synchronous altitude, tidal forces from Mars are slowly lowering its orbit. In about 50 million years, it could crash into the surface of Mars, or it could go into a ring structure around the planet. The need to study the past is not unique to planets. This need applies to all things in the universe, including our planet.